All right, so 1, 5, I put 2 slides because there was a second one I added. This is all the combined functions when you're dealing with equations, like the algebraic ones. So with A, you could have either taken G and added it to H and then plugged in the 4, or you could have done the G of 4 and the H of 4, which is basically what's here. G of 4 and then H of 4, and then added them together. So the G of 4 would be the square root of 4, which is 2. The H of 4 would be 4 plus 3, which is 7. And then because this is addition, we add them together, and you should have gotten 9. The F times G of 2 would be F of 2 times G of 2. F of 2 is 1/2. G of 2 is the square root of 2, and you end up with just root 2 over 2. That can't be simplified. If you left it as like 1/2 times square root 2, I gave it to you. It simplified most. I would have given it to you. Sorry, it would have been to combine them together. For C, now we're doing the combined function with the equations. So we're taking the f of x and we're plugging it into the h of x. And that would result in 1 over x plus 3. Then because it said domain, we want to look at the original one we plugged in. So we want to look at the f of x here and see if there's a domain restriction. And there is. X can't be 0, okay? So from there, x cannot be 0. But then I want to also look at it after it's combined. So if this had changed, so it was like 1 over x plus 1 in the denominator, now there's a new restriction. It couldn't equal -1 or 0. But because it's still just x in the bottom, x cannot equal 0. And there's the domain of my function. It should be an interval notation, -infinity to 0, and then 0 to positive infinity. Questions on these? Good job. So that's Alex. So I'll give you candy at the end if I screenshot. So if you were neat and correct, I screenshot your answer, pulled it in. So this was your last one. This was also 1.5 though, so that's why I wanted it in this order. Okay, 1.5 with graphs. So for A, you can't plug in here, right? You're not gonna, I don't want you to find the equation from your graph and then plug in. I want you to use the graph. So this is saying that f of 3 minus g of 3. So I'm going to go to my f graph, which is the one on the left. I'm going to find where x is 3, which is here, and find the corresponding y, which would be 2. So that's 2 minus. Then I go to the g graph. 3 is here. I find the corresponding y, which is here. That's 1. And my answer is 2 minus 1, which is 1. Underneath that, f times g would be f of 2 times g of 2. F of 2 is actually 0, so it doesn't matter what my g of 2 is, but I'm going to go there anyways. G of 2 is 2. And 0 times 2 is 0. Go to the second A. I know there was 2 A's. Would be f of g of 4. So I first have to find g of 4. G of 4 is here. That coordinate point is 0 for the y. So I find f of 0. I come over here, and the coordinate point is 4. 4 is the only answer there. So it's the second thing you find, not a 0 and a 4. That one a lot of you missed, so be careful with that. B is g of f of 1. So we start with f of 1, which is here. The answer there is 2. And then I find g of 2. Go to the other graph. G of 2 is here. Coordinate point's here. And that y is 2. Then came 1, 6. So this was our inverses. A had an inverse because x is not raised to an even power or an absolute value. Switch the x and the y, solve for the new y, and then last step, make sure you make it f -1 of x. Oh, that was no, let me forget. That was last one was yours. Okay, this is Lucas. So then you get f -1 of x equals x plus 3 over 2. B does not have an inverse, or it's not 1-to-1 because it has an even power on the x. And C would be f -1 of x equals x to the third minus 2. Questions on those? Yeah. Right. That's why it can't be done.
Oh, I thought it said no even power.
Oh, no, comma, the reason is even power. That's my assumption. Is that what you meant, Lucas? Yeah, I would have given it to you. Okay, then 2-1. This was like your kryptonite, so be really careful. A lot of people mess up on this stuff. So we want to take out, first we're going to group together the 2x and the 2x squared and the 3x. We're going to leave that space there. We're going to take the 2 out. By taking out the 2, we're dividing both these terms by 2. Most of you did that pretty well. And I get to here with the space. Then I have to take the 3 halves. I have to divide it by 2 and square it. 3 halves divided by 2 is the same thing as 1 multiplying by half. So I'd get 3/4, and 3/4 squared is 9/16. 9/16 is what you want to add inside the parentheses. And normally I would be subtracting 9/16 from outside the parentheses. But you have to multiply by 2 first. So 2 times negative 9/16 simplifies to negative 9/8. So now she left it as 18/16, which is fine. You just have to simplify at the end, or you simplify it now to make that negative 9/8. And then I'm doing negative 5 minus 9/8. This is negative 48 minus 9/8, which is negative 49/8. So a lot of you made a mistake on that step. And think about it, if you just, so if its question is just this, complete this square, you're going to lose partial credit because you're going to get the K wrong. But if you use complete the square for the second question, now everything involving your vertex is wrong. Your graph is wrong, your vertex is wrong, your range is wrong, your max is wrong. 4 parts are going to be wrong if you get that one little step wrong if you're trying to complete the square on the second question. So if you know that you're not the best at the fraction work, you're not going to be able to avoid it completely, but maybe stick to the negative b over 2a option, okay? If the fraction's dealing with the complete the squares that's getting you.
For this answer for the end was negative 49/8, do you want it in fraction or can it be mixed?
Because it's not used to graph, you might as well just keep it improper. If I was graphing this, you'd obviously have to convert that. But I would take out either, like if you put 6 and 1/8, it's fine, it's not wrong. But it's an extra step you don't need to take. So the only other thing I would say is make sure this is a y equals or an f of x equals. Good job. That was Helen. Good job. So then you have to factor it, right? So we're at this step. We're at 2x squared plus 3 halves x plus 9/16 minus 49/8. That's where we left off. Then I want to factor it. So the 2 stays on the front, and that's a common mistake people make on this every year is forgetting the leading coefficient. Don't forget that. You took it out. It's still part of your equation. Then I square root the first term. I square root 9/16, which goes back to before I squared it over here, or 3/4. Take the sign from the middle, and the sign from the middle is plus. Put it in the parentheses, square it. Minus 49/8. And there's my equation, equals f of x. Okay. So again, that in itself is one question. Use complete the square to put this equation into standard form.
So you put f of x 1 y?
Yeah, I would take either one. Okay, so this is standard form completing the square. I'm going to start by grouping the first 2 terms together. Bump the 5 to the outside. Now I got to take out this 2. So when I take it out, it comes off of the x squared. It also comes off the 3x. So this is x squared plus 3 halves x. Then I take that 3 halves, I divide it by 2 and square it. So 3 halves divided by 2, same thing as multiplying by half. And I get 3/4 squared, which is 9/16. I'm going to add that here. And then normally I would subtract it out here to balance out my equation, but I've got to multiply it by the 2 first. This simplifies to be 9/8, negative 9/8. So I've got 2x squared plus 3 halves x plus 9/16. Negative 5 minus 9/8. I have to change them so they have a like denominator, which would be 8. So this is negative 48 minus 9/8, or negative 49/8. Now I factor. Square root the first term, square root the last term, take the sign from the middle, put it in the parentheses, and square it. Minus 49/8. This is either a y equals or an f of x equals. I won't mark either of those wrong, doesn't matter. But that's the goal for completing the square. And there's a question that's just going to ask just that, and you're done. Then there's a question like the next one, which says you can use this same format to graph, or you could use the negative b over 2a, but it's going to be a different equation, okay? If I were to start from scratch, I would do the negative b over 2a. So I'm going to do negative b over 2a, which is negative 3 over 2 times 2, or negative 3/4. And that's the x coordinate of my vertex. Then I would take that and plug it back in to all the x values. 2 9/16 plus or minus 9/4 plus 5. This reduces to 9/8 minus 9/4 plus 5. I need them all to have the same denominator, so this becomes 9/8. 2 and 2 here, 18/8. 8 and 8 here, 48. And I get negative 9/8 plus 48. Wait, this should be minus. This on the right, it's a minus on the initial. Am I right? Yeah, sorry, that should have been minus the whole way. So this would be minus. Negative, the question itself was minus 49/8. Yeah. When you compare this to your standard form, which was 2x plus 3/4 squared minus 49/8, it should be the same vertex. I don't want you to spend time doing it both ways, okay? On the quiz tomorrow, you won't have time to do it both ways. But if you are a quick worker and you want to check it that way, that's totally fine. So that's my vertex, right? Then I've got x-intercepts, which are going to come from factoring, and you will be able to factor tomorrow's. So I'm going to take this, and I could factor it. So I could do either trial and error or multiply the first times the last. Negative 10, find the factors of negative 10 that sum to positive 3, which are positive 5, negative 2. Replace your middle term, and then factor by grouping.
Can I take a picture of that?
Mm-hmm. And I get 2x plus 5 and x minus 1. Or you could have done trial and error. It would have been factors of 2x squared and then factors of 5, negative 5. One would have been positive, one would have been, so until you got to, was 2x plus 5x, which is positive 3x, which matched the middle term. So now I would split and solve these, and I get that my two x-intercepts are negative 5/2 and 1. Your y-intercept, remember, is super easy from here. It's 0, 0, and it's just whatever c is, which is negative 5. So when I go to graph this, that's enough information. I've got negative 3/4, is so sloppy, but negative 3/4 and negative 6 1/8. I've got negative 2.5 and positive 1, and then my y-intercept at negative 5. My domain is all real numbers. If you want to write that on your quiz as soon as you get it, feel free. You know you get some points to start with, okay? The range would be from negative 49/8 or negative 6 1/8 to positive infinity. And your axis of symmetry is x equals negative 3/4. Does this graph have a max or a min? The min, and it's the k coordinate of my vertex, or negative 49/8.
Is it 5, negative 5/2? That would be like around,
It's negative 2.5.
okay.
Yeah. Oh, wait, sorry. This time I asked you to carry over it just for time's sake, but tomorrow you'll get a completely different question for this one. It will be a new quadratic. It will be one in which there's a term on the front you'd have to take out. So you have choices. Either you work through it, complete the square like we just did, get it into standard form, or do the negative b over 2a. So if you do the negative b over 2a, you would have gotten that same answer, right? So it was 2x squared plus 3x plus 5, right? Negative b over 2 times a gives me negative 3/4, and that's the h coordinate of my vertex. Plug that back in to get the k, and you should have gotten negative 49/8. Again, it won't be the same equation for both questions. You'll start fresh with a second one. And I would say use whichever option is better for you. I would probably choose the negative b over 2a because it's going to be a yucky complete the square again. Yeah.
And any of the questions will we be forced to do a complete square?
Yeah, the last one. Yeah. Like the last example we just did, there's a question just like that. Yeah. This one, you'll get a new equation, but you have a choice. Okay, then the intercepts, and this is factorable. If I factored it, which is down here, Okay, you should have gotten 2x plus 5 and then x minus 1. It will be factorable. I'm not going to make you do the quadratic formula just yet. And you would have gotten negative 5 halves and positive 1 for your y-intercepts. And then use this equation at the top to get your x-intercepts because your y-intercept, sorry. If this is 0 and this is 0, then it's 0, 5. So y-intercept 0, 5, x-intercept negative 5 halves, 0, and 1, 0. From there, go to your graph. Your vertex and your intercepts are enough to graph it. This has a minimum. You're going to tell me which one, whether it's a min or max, and then it's the k value, which is negative 49/8. Your domain is all real numbers. And, oh, it's on here. And your range is the minimum value, which is that negative 6 and 1/8, or negative 49/8. You can leave it like that. Comma, positive infinity has to have a bracket on the number. So the infinities get the parentheses, but the number gets the bracket. And then your x-axis of symmetry is x equals h. Our h is negative 3/4, so it's x equals negative 3/4. Questions on that one? So this question is worth more points. I think this is like a 20-pointer. It's a double. Or around there. I think I made each part. So I think it's 24 points is what it is. And then the equation, which I think is such an easy question, and every year somebody screws it up because they haven't practiced it. Just make sure you practice it. The most common mistake is not squaring. We forget to square. My equation is this: a times x minus h squared plus k. Here's my x, here's my a, here's my k, there's my h and my k, and this is my x and my y. So I'd get 8 equals a 2 minus a negative 1 squared plus 4. You have to square this first. So this is a times 9. People, for some weird reason, regroup these numbers and add those together. Order of operations says multiplication comes before addition. You can't separate that. So then I'd subtract the 4, and I get 4 equals 9a. Divide both sides by 9, and I get a equals 4/9. Plug back in the a, the h, and the k, and you get your equation. Good job, Andres. Questions on that one? So this is my HK. Passes through 2, 8. This is my XY. I am not giving you the equation at the top on tomorrow's quiz, so make sure that you know this. Y equals a x minus h squared plus k. Then I take and plug in. So the x, or the 8 goes in place of the y. The x gets the 2 minus a negative 1 be plus 1 squared plus k, which is 4. I get 8 equals a 3 squared plus 4. 8 equals a times 9 plus 4. At least once in this quiz, somebody combines these together first. That's wrong, okay? That 9 is part of the a. You can't separate those. You got to subtract the 4. 4 equals a times 9, and then divide by 9. And a is 4/9. So then I plug back in the a, the h, the k. So this is y equals 4/9 x minus a negative 1 would be plus 1 squared plus k, which is 4. Oops.
And that's the final equation, right?
That's the final equation. Wait, y equals 4/9. Okay. This question is not on the PDF that's already there, that like an extra practice on it. I'm going to type it right in the box so that hopefully, and when I go put the answers on, it will be there. Make sure you practice that question because obviously it's on your quiz.
Can you go back to the intercepts?
Then this question came up in the homework. So it says you have a steel wire that's 100 inches long. To make a sign holder, you bend the wire x inches from each end to form 2 right angles. Use the sign holder. To use the sign holder, you insert each end at 6 inches into the ground. Write a function for the rectangular area A enclosed by the sign holder in terms of x. So basically it gives you the diagram with your length and your width already set up. You just have to find area. So this is a great application question. This is a great standardized test question. Area of a rectangle is what? Length times width. So I would have to do 100 minus 2x times x minus 6. I'd have to FOIL that out. 100x minus 600 minus 2x squared plus 12x Combine your like terms here, so negative 2x squared plus 112x minus 600. That was the first part. Then it said use the table feature of the graphing utility to determine the value of x that maximizes the rectangular area enclosed by the sign holder. You don't even need your table value. Your table value, you're basically looking for the biggest y. You could have done this without your calculator because basically they're looking for k here. So you could do negative b over 2a, plug it back in to get the k. So if this was on a part of the, let's say this was on the SAT or ACT and this was on the part that didn't have a calculator, I would do that, so plug back in to get k. It would be smaller numbers if that was the case. Or you go to your graph, it's going to graph your function on your graphing utility, and you find your max. Your max coordinate point is going to be that negative b over 2a, and then the k in this case would have been 28. So your maximum value there should have been 28. That's how you would have found it. Yeah.
Is that around the
Quiz, no. Test, there will be a quadratic that you're going to have to graph on a graphing utility and answer a question. It could be a 0, like it could say what's a 0. It could say what's the max, so something like that. But that would be test, not quiz. Quiz, you won't have your graphing or a calculator at all. Any other questions for me for quiz prep? So again, tomorrow, 1-5 to 2-1. If you were comfortable doing the class kick today and the PDF that's posted, I would say you should be good to go. If you're not, that's your job today. If you know that you're slacking in the complete the square department, then that's where you need to practice. If it's in the quadratic, wherever it is that you found you struggled today in that class kick, you need to make sure you focus on. Tomorrow when you come in, I'll be able to answer questions on the quiz review first, and then you'll take your quiz the second half of the class. I'll probably give you the 30 minutes at the end.